Welcome to Spring LIB.
Hi everyone, so what we have here is a spring-held follower that has a mass of 0.5 kilograms, and it moves back and forth on a contoured surface that has an R equal to 0.5 meters, and the contour is given by Z equal to 0.02 cosine of 2 theta. We know that the cam is rotating at a constant rate of 30 radians per second, and that the spring has a spring constant of 1,000 newtons per meter. What we're asked to solve for is the force in the z direction at the end of the follower when theta is equal to 30 degrees. And how we're going to be doing that is using our knowledge of acceleration in the linear directions, linear and rotational directions. And we're going to be using that with Newton's second law to develop our equation of motion to solve for this force. So what we're going to do first is write down our motion in z. So we know that z is equal to 0.02 cosine 2 theta. Next, what we can do is we can take the derivative twice to get our acceleration in the z direction. So we get that z dot is equal to negative 0.4 or 0.04. 0.04 times the quantity cosine of 2 theta times 2 theta dot times theta dot plus sine of 2 theta times theta double dot. And for theta dot equal to 30 radians per second and for theta double dot to equal 0, this gives us a z double dot that's equal to negative 72 cos 2 theta. So we can go ahead and plug in for our theta. We know our theta, which is equal to 30 degrees. And this gives us a z double dot that's equal to negative 36 meters per second squared. Next, what we can do is we can draw our free body diagram. So here is our, here's the end of our follower, and our spring. So here we have our normal force, and here we have our spring force, so we'll just call that FSP, and this is all in the z direction, and this is the direction of the acceleration in z that we want. So when we know that theta is equal to 30 degrees, we know the spring will compress a distance that's equal to x equals to 0.02 plus 0.02 cosine of 2 theta. And this gives us an x distance of compression equal to 0.03 meters. Therefore, our spring force, FSP, is just going to be equal to k times x, which is equal to 30 newtons. So now what we can do is we can write our Newton's second law and say that the net force in the z direction, which we know to be equal to m times az, we can say that this is n minus 30 because the Fz and spring force are acting in opposite directions, and that's equal to our m times az. Recall that we solve for az and m is given to us, so this gives us a spring force n, which we will call an Fz force that's equal 12 newtons, and that's our final answer.